will solve this problem. They give me the function and they want to find nearest point to the origin. That's why we need to apply Lagrange multipliers. Firstly, if they say that nearest point to origin, we suppose that origin gx y equals to x squared plus y squared. So now we find derivative for x in f function, and we get that fx equals to 2x, and we add component vector to xi. Then we find the derivative for y. Then we get that fy equals to y 4y, and we add component vector j. We also find derivative for this function for x, gx equals to 2x. We add again component vector and gy, and we get that 2y and j. So as I said, we apply Lagrange multipliers method, and we get that this equation. So, and we substitute our findings here, and we get that 2xi plus 4yj equals to lambda multiply 2xi and 2xi 2yj. So, and we get that 2xy equals to 4yj and equals to lambda 2xi plus lambda 2yj. So we get this, and we equalize. We see that the component vector is the same. That's why we equalize these parts, and we get that 2x equals to lambda 2x. Also, for y equals to lambda 2y. So we have two options. X can be 0 and lambda can be 1. If lambda 1, so it means that automatically y should be 0. And also in this part we have two options. Y can be 0. This part belongs here. Also, y can be 0. Also, lambda can be equal to 2. So we also get that if lambda equals to 2, it means that x automatically 0. So we get these findings. As you know, our equation is like that: x squared 2y squared equals 1. So we substitute our findings first here, and we get that if squared plus 2y squared equals 1. So we get that y equals to plus minus 1 over 2. And we say that also lambda equals 1, so it means that automatically y equals to 0. So we get that x squared plus 0 squared plus equals to 1. So we get that x equals to plus minus 1. If we find this version, also we find this version, so we get the points like this. In this part, x equals to 0, that's why we get 0, 1 over 2. So another point, x again 0 and minus 1 over 2. So in this part, we suppose y equals to 0, that's why we get that 1, 0, minus 1, 0. So this is our point, but they ask that which is the nearest point. So we get our points. So they ask that which is the nearest point, and we substitute our points in this equation, in this function. This is the origin. So firstly 1, 0, and we get that 1, 0, and we get 1. Minus 1, 0, we get again 1. So and this point 0, square root 1 over 2, and we get 1 over 2. So we have another point, again minus square root 1 over 2, and we get 1 over 2. So we see that these points are the same distance from the origin. That's why we say that actually we can write this one like this. So we say that these points are the same distance from the origin, and we solve the problem. I hope you understand this. See you soon.